Hi everybody, welcome to My Physical World. In today's episode, Cartography, we're going to talk about the basic characteristics of maps. Location and attributes at locations are the two fundamental elements of reality of all maps. Location is simply its geography, where it is. Usually it's some two-dimensional coordinate. In this case, cities in the United States, shown by latitude and longitude. Attributes at locations are descriptive characteristics of the location, some quality of the place, such as temperature, population, socioeconomic characteristic. And it's from location and the attributes that we can analyze some relationship. For instance, location to location. We can simply look at 2 points and analyze them by their geography, by their latitude and longitude, Texas versus North Dakota. We can also look at a single location and analyze its relationship based on all of attributes that describe that location. We can also look at multiple locations and analyze those locations by maybe a single attribute, such as elevation between these 2 points. And finally, we can look at multiple locations with multiple attributes and analyze those relationships. Now, maps also hold a dimensional relationship between the map itself and reality. This is called scale. Scale is important because it defines the precision of the information being conveyed. Here I have a map of the United States on my computer screen, and I'm currently showing it at roughly 1 to 23 million. What that means is, from coast to coast, east and west of the United States on my map, it would take 23 million of these dimensions to equal that same dimension in real space. If I want to increase the precision of the map data that I'm looking at, in this case, we can zoom in. We're increasing the position of these cities by increasing the scale that we're looking at. Since I've zoomed in to Texas, now we're roughly 1 to 4.5 million, which is the scale. All maps also attempt to convey information that's found on a spherical object, such as Earth, to a flat page, either a printed page or a digital page like we're looking at here. Therefore, some transformations are necessary. These systematic transformations are called map projections. And map projections dictate the accuracy of the geographies. Here we can come up to this. Currently my United States map is not projected, but I can easily come into my software in this case, and I can choose a map projection that better conveys a spherical object, such as this conic projection here. Now, since the Earth is so wonderfully complex, even the most detailed maps are simply abstractions of reality. So, cartographers are inclined to use symbology for translations of that reality. Over the years, this symbolism has evolved into translatable schemas, such as standardized symbols for topographic maps or possibly interstate systems in the United States. Maps go beyond language barriers. For instance, you can easily make a map without using words to convey some type of information. Maps are kind of like math. They're universal. Here in my example I have, even though I did use words, I can just simply use a date and show two images of the city of Dubai and show the change over time. People would understand that this image is older than this image and change has happened. I did not have to use words to convey this information. And finally, data is portrayed on all maps by different types of marks, such as lines, points, areas, colors, tones, and patterns. So these were all the basic characteristics of all maps. If you guys have any more information that you want to add, you are welcome to add them to the comments below. I invite everybody to subscribe to My Physical World so we can explore our physical science together, including cartography and physical geography, meteorology, and all that kind of stuff. So we'll see you next time on another episode of Cartography. We'll see you later.